and you can't take differences, it gets a little bit messier, so I'm just going to skip that. Alright, so now we're going to do this for proportions. So again, the setup is exactly the same. Hypothesis test. You can have, again, we can do the exact same thing. Again, imagine we're going to ask the same question, but maybe we're going to have men as one group and women as the other group. So you're going to have the proportion of men compared with the proportion for women. And again, as far as hypothesis tests go, you can have the same three setups. Different, greater than, less than, exactly. Okay. And let me also make a quick comment here. Notice that for proportions, we're not going to be able to do match pairs because you don't have means. Remember what a proportion is? It's a bunch of people saying yes and no. So you can't do yes minus no. So throughout this problem, we're going to have to be very clear about which population we're talking about. So we're going to say this is the stuff for the first population, and this is the stuff for the second population. So everything is going to get labeled as 1 or 2. So P1, the proportion in the first population, P2, the proportion in the second population. Okay. Like this. Okay, so let's look at a sample question. Alright. So we claim that the proportion of men who were smokers is higher than the proportion of women who were smokers. So, first of all, what does P1 stand for and what does P2 stand for? Right. Okay, so we're going to let P1 be a proportion for men, P2 be a proportion for women, smokers. And what would our claims be for this statement? For this question? Right. So you get HO P1 equals P2 and H1 P greater than P2. So that's the first thing. The second thing is, I'm now going to throw in some data. So let's say that we do a survey. Out of 2,103 men, 547 smoke. And then out of 1,671 women, 368 smoke. All right. Okay. Alright. So this is just a reminder. Indices are the little 1s and 2s. So everything that we write down is going to be marked with a 1 or a 2, so we know which population it refers to. Notice that, for example, you can't say, what is N? What is N? You can't say. What do you have to ask? You have to say N for the men and then N for the women. And how are we going to write that down in notation? N1 and N2. Exactly. So one thing to be careful of is, as you're going through the problem, 1 represents which group? Men, and 2 represents which group? So I think it goes without saying that you don't want to get confused halfway through the problem and switch. So you have to keep this in mind, which group is which, as you're writing these things down. Okay, so let's go ahead. So again, our hypotheses are P1 equals P2 and P1 is greater than P2. For part of our calculations, it's going to be useful to think of this as the difference. Now notice that when I say difference, I don't mean that we're going to go and take the difference person by person by person. We're simply going to compare the proportion for the first group and the proportion for the second group as a whole. Make a note of that. Okay. So, okay. So let's see. So what are we going to need to do? Okay. Is there such a thing as a p hat? Not in this problem. What is this problem going to have? There's no p hat. There's no d hat. Remember, we do need a proportion for the sample, but which sample? P1 and P2. So we need a P1 hat and a P2 hat. Exactly. Okay. So how do we find P1 hat? Right. 547 out of 2103, and that equals. Yep, you got it. And then we also need P2 hat, and that is 368 out of 1671, and that is 0.2202. Alright. Now, for the purposes of doing our calculations, you're going to see this more clearly in a minute. We want the difference between the two sample proportions. So, P1 hat minus P2 hat, and that works out to 0.0399. Okay. Now, where to go from here is a little unclear. Yeah. Sorry? That's what we're about to see. Alright. Okay. So for a moment, let's just very naively, let's just draw the. So let me just tell you right now, you don't need to do the normal check for these. Just assume that they're normal. So let's just draw the normal curve. Okay. And we know that one of the things that we're going to need to find at some point is a z-score. So the question is, what is the formula for the z-score? Okay. So for a regular proportion problem, what's the formula for a z-score? P hat minus the mu for p hat, and then divided by sigma for p hat. Okay. So the trick that we're going to do here is that instead of talking about p hat, we're going to talk about p1 hat minus p2 hat. So instead of talking about the proportion, we'll be talking about the difference between the proportions. So instead of p hat, we're going to have p1 hat minus p2 hat. Right. And instead of mu for p hat, it's going to be what? Mu for p1 hat minus p2 hat. And instead of sigma for p hat, it's going to be sigma for. Exactly. And okay. So of these things, which ones do we know? Do we know p1 hat minus p2 hat? Yes. Do we know mu for p1 hat minus p2 hat? Yeah, we do. Where does that come from? It comes from the hypothesis, and what is the number in the hypothesis? 0. So we have it already. So the only thing that we need to know is, how do you find this standard deviation? So the one thing that I have to do is I have to give you the formula for that. So first, a quick reminder. What was sigma for p hat? It was the square root of okay. So keeping that in mind, and the fact that we now have two different populations, here's the formula for sigma of p1 hat minus p2 hat. It looks complicated, but it's not. Why is this not complicated? Look under the square root. What is under the square root? No, it's like this. What is under the square root? There are two pieces. What does the first piece look like? The standard deviation for p hat for the first one. And what does the second one look like? Standard deviation for p hat for the second one. Sorry? Right.
Also, you could do like different, like separate.
Yeah, if you want, you can even calculate them separately.
But then you will have to add them together, right?
Exactly.
Oh, okay.
So again, while this formula looks like a mess, it's really based on stuff that we already know. So just remember that you have to do it first for the first population, and then for the second population, or first sample, second sample, and that's the main thing. Okay. So now let's go ahead and calculate it in this problem. So sigma p1 hat minus p2 hat equals, let's fill in all the numbers. P1 hat was 0.2601, then times 1 minus 0.2601, divided by n, which was n1, which is what? That was 2103. Then plus, same thing but for the second sample, 0.2202 times 1 minus 0.2202 divided by 1671. Okay. So now it'll take like a minute or so to work this out using a calculator. If you've got a nice calculator, or you understand how to type this into Excel, you can do it all at once. You might want to do this in 2 or 3 steps. Figure out the first part, figure out the second part, then add them, then take the square root. That might be the easiest way to do it. Once you have all that, this works out to 0.0139. So now let's go back and fill in our. So once we know that, let's go back and fill in our picture. So first of all, we've got Z. Now, how do we label the second row? We used to label it P hat. What are we going to label it now? P1 hat minus P2 hat, exactly. Now, what goes in the middle for Z? 0. What goes in the middle for P1 hat minus P2 hat? 0. The mean, which comes from the hypothesis. Now, what other number do we put down here?
On the right side, you can take
What number do we have for P1 hat minus P2 hat? 0.0399. That's exactly it. And then what else do we do? Shade where? Shade to the right because it's a greater than problem. Okay.
You got 40399 and subtracting 2601 and 2202, right?
Yes, exactly, because we're writing down values for P1 hat minus P2 hat.
Okay.
So that's how we found our value. Okay. So next we need to find. So what do we need to do next? We need to find our z-score. We now have, after working through all that, we now have all the pieces to find the z-score. Because the formula for the z-score is just P1 hat minus P2 hat minus mu for P1 hat minus P2 hat divided by sigma for P1 hat minus P2 hat. And we have each of those three numbers. P1 hat minus P2 hat was 0.0399, the mu was 0, and the standard deviation, we just found it. It was 0.0139. So we have that z equals 0.0399 minus 0 over 0.0139, and that works out to 2.8705. So, let me actually.
On the homework, would there be a proportion problem like this with confidence intervals?
Yes, and I'll talk about that briefly in 1 second. Okay. So we have our z-score. Oops. 2.8705, and now what do we need to do? Now we just need to find the area, and this we know how to do. Normal distribution, our z-score is 2.8705. That gives us an area of, let's see, 9979. We round it 0.9980. Just 0.0020. So what's our conclusion? 0.9980 confident that what? Right. Higher proportion to be technically correct. Right. Okay. So there you go. Okay. So it's a little bit of a mouthful. There are one or two more moving parts than we're used to, but again, remember, it's all the same, just a little bit different. Okay.